In this video, we're going to look at algebraic fractions. Let's start with adding and subtracting fractions and consider some basic numeric examples. If we're adding or subtracting fractions, the denominator must be the same. So for example, if we were asked to add 1/3 and 1/5, we would need a common denominator. One way we could do this is to cross multiply. So we would multiply now the 5 and the 3 in the denominator, and we'd now have one lot of 5 plus one lot of 3. So that's cross multiplying. So we'd have 5 plus 3 in the numerator, which is 8, and in the denominator we'd have 15. Cross multiplying isn't always the most efficient way to add or subtract fractions. When we're dealing with algebraic fractions, we're going to take a different approach, and that is to find the lowest common multiple and consider equivalent fractions. So let's see why this isn't the most efficient way to always deal with adding and subtracting fractions. Let's say I had now 1/3 plus 1/5 plus 1/15. If I try to cross multiply, that's going to be a nightmare. We're going to end up with some massive numbers, and in reality we don't need to do it. And the more and more I add or subtract, the more and more work we're going to create. What we look to do is find the lowest common multiple. We want the lowest common multiple of the denominators. So what is the first number that 3, 5 and 15 go into? The answer is 15. So what we would do is write equivalent fractions. So if I wanted to turn this fraction into 15ths, what would I need to do to the numerator and the denominator? The answer is multiply the numerator and the denominator by 5. So we'd end up with 5 over 15. What would I need to do to the 1/5? I'd need to multiply numerator and denominator by 3. So we'd have 3 over 15. What would I need to do to this one? The answer is nothing, as it's already now in the lowest, it's the lowest common multiple in the denominator. That just leaves me now to add the numerators. So we'd have 5 plus 3, which is 8, plus 1, which is 9, over 15. We would then look to simplify, and we can see this divides by 3, so we could say that that would be 3/5. So that's our answer as a single fraction. We could see another example of why cross multiplying is not the most efficient way to add or subtract fractions. Let's say I had 1/4 plus 3 over 8. If I cross multiplied here, in the denominator I'd have the 4 times by the 8. In the numerator I would have one lot of 8 plus now 3 lots of 4. So in the numerator I'd end up now with 8 plus 12, which is 20. In the denominator I'd have 32. And then I'd have to go ahead and simplify. And I'd end up now with dividing top and bottom by 4. I'd have 5 over 8. What we could have done here is just considered that this could be written as eighths. So instead of 1 over 4, we could just write that this was 2 over 8. 2 over 8 plus 3 over 8 quite clearly is going to be 5 over 8. So when we're dealing with adding and subtracting algebraic fractions, we're going to look at finding the lowest common multiple of the denominator and consider equivalent fractions. So let's go ahead and start with a basic example. Let's say we were asked now to add 1 over the quantity x plus 1. X plus 1 is just a linear factor, and we wanted to add to that now 2 over x minus 3. We can see from here now that these are two different denominators. We need a common denominator, and in this particular case the common denominator is the multiple of the two. So all I'm going to do is have a single fraction. I'm going to have the two brackets. I'm going to have x plus 1, and then we're going to have x minus 3. I say to myself, what did I multiply this fraction by to get the common denominator? And the answer is I multiply the numerator and the denominator by the x minus 3. So all I've got is one lot of x minus 3. What did I do to this fraction to get the common denominator? I now multiplied top and bottom by the x plus 1. So writing this now, we've got two lots of x plus 1. Now you might think, well, all I can do is cross multiply. In a later example, we'll see why that isn't the case when we're looking at the lowest common multiple. So let's write out the numerator. We've got x minus 3 plus, and expanding the brackets, we've got 2x plus 2 over now these two linear factors, which we wouldn't expand. We're not going to expand them just in case something cancels off later on. So x plus 2x is 3x. We've got minus 3 plus 2, which is minus 1, over these two linear factors. So this now is a single fraction in its simplest form, and that is the terminology that will be used in most questions. Express now 1 over x plus 1 plus 2 over x minus 3 as a single fraction in its simplest form. Let's look at another example. We'll do some subtraction. So let's say we've got 3 over x plus 4, and then we want to subtract from this now 5 over x minus 1. So what's our common denominator? It's the product of these two. So we're going to have x plus 4, and then we'll have now x minus 1. I say to myself, what did I multiply this fraction by to put it over the common denominator? And the answer is I multiplied numerator and denominator by x minus 1. So we'll have 3 lots of x minus 1 minus 5 lots. What did I multiply this fraction by? The answer is the linear factor of x plus 4. If you want, you can write two fractions and then combine them at the end. If you don't like this approach, you can simply write now here, and what we could do, let's do this. Let's say we've got now 3 lots of x minus 1 over x plus 4 multiplied by x minus 1. So if you want to consider now these as single fractions, then add at the end, you can do. I think taking that step out here just makes things slightly less work to do. So let's go ahead and expand these brackets and tidy the numerator. We need to be careful here, we've got a minus 5. So let's just write out the numerator, 3x minus 3, minus 5x, and we need to be careful here, that's going to be minus 20. Sometimes students just put now plus 20 because they see the plus 4, but remember, it's a negative here. We don't expand the denominator, we leave this now as the product of two linear factors. So we have now 3x minus 5x, which is minus 2x. Then we have now minus 3 minus 20, which is going to give me now minus 23. So that is all over now x plus 4 and then x minus 1. Now this can be written in a couple of different ways. I can factor out a minus, so we could write minus the quantity of 2x plus 23 over now these two linear factors of x plus 4 multiplied by x minus 1. So either give exactly the same numeric answer if you sub in a value for x, but it's just a different way of reading it. If you wanted to check if you got a different answer to what the mark scheme had, just sub in some values for x. So as long as x doesn't equal now minus 4 or x doesn't equal 1, just sub in some values. The reason we can't have those is because this would give us 0 in the denominator. And of course we can't divide by 0. So just check a value, just sub in for example 2 and check now whether 2 would give you the same answer as what you have in the mark scheme. So these two examples we could have cross multiplied. Let's look at an example where that wouldn't be the best way to do this. Let's say we had 8 over now the linear factor of x minus 1. So linear in the fact that it's just x rather than x squared or x cubed. Plus now, let's say we had 3x over now x minus 1 all squared. Now the fact that we got a 3x in there doesn't matter. We could have just had 3 or we could have had something completely different. This isn't having any bearing on the learning that we're going to do here. If I take this back, and this might help, you can look at it this way. If I've got 1 over 4 plus now 3 over 8, I've actually got 1 over 2 squared plus 3 over 2 cubed. And what we do is take now the 2 and we raise it to the highest power. That's what found us the lowest common multiple when we were looking at numeric examples lower down the school. So for example, now if you had, let's say we got 1/3 plus 2 over 27, we would have 1 over 3 to the power of 1 plus 2 over 3 to the power of 3, and the lowest common multiple would be 3 to its highest power. So let's look at what we've got here. We've got x minus 1 and x minus 1 all squared. The lowest common multiple is x minus 1 all squared. If I just write this out in long form, what we've got, and this wouldn't be expected, we'd have now 3x over x minus 1 multiplied by x minus 1. So if we take it back to this scenario here, we can see that we would take now the linear factor of x minus 1 to its highest power. Therefore, we now write that the lowest common multiple is x minus 1 all squared. So I say to myself, what did I need to multiply this fraction by to get the common denominator? And the answer is the linear factor of x minus 1. What did I need to do to this one? Well, I don't need to do anything because it's already over the lowest common multiple, so we end up now with 3x. So expanding this out, I get 8x minus 8 plus 3x over now x minus 1 all squared. So essentially I've considered equivalent fractions using a lowest common multiple. So what do we end up with? 11x, what have we got? 11x minus 8 over x minus 1 all squared, and we check that it's a single fraction in its simplest form. Now, what if had happened if I tried to cross multiply? Let's just think of the mess we would have. We'd have x minus 1 squared multiplied by x minus 1, which is x minus 1 cubed. I'd have 8 lots of x minus 1 squared plus 3 lots of x multiplied by x minus 1. And it would have taken loads of expansions and loads of refactoring just to do it. So whenever we're dealing with these, we go ahead and find that lowest common multiple. And it's often nice to just think back that the lowest common multiple is simply every factor to its highest power. Let's have a look at another example. So let's say we've got now, and we'll do another addition. In terms of addition and subtraction, it really doesn't matter an awful lot. The technique is exactly the same. You're just simply subtracting instead of adding. Let's say we've got 2 over the quantity x plus 2 plus 3 over the quantity x squared plus 2x. Let's say we have this and we wanted to now go ahead and add them. Now at this stage it looks like we're going to have to multiply these two to get our common denominator. We need to just be a bit careful, and often we can use factoring to work around this. So if we rewrite this, we've got 2 over now x plus 2, and then I'm going to add to that and just factor in this one. We got 3 over and taking the common factor of x, x plus 2. So we can see at this stage the lowest common multiple becomes slightly easier. We've got x plus 2 to the first power. We've got x plus 2 to the first power, so we know that's going to be part of our common denominator. But we've also got this x. Therefore, the lowest common multiple, or the lowest common denominator, is x, x plus 2. So we take every value in the denominator to its highest power, and this is just x to the first. So what do I need to multiply the numerator and denominator of this fraction to get my lowest common multiple? The answer is just the factor of x. So we get 2x, and then we'll have plus the 3, and that will all be over now the x multiplied by x plus 2. So just tidying it up, I suppose it's no different, we can write it like so. So that now is a single fraction in its simplest form. So why is this useful? Let's say in an exam question we were asked now, we were given this and we were asked to solve the equation where this is equal to 1. All we would do is go to this point right here and rewrite it. So we could say that 2x plus 3 over, now, and let's just put this bracket there, 2x plus 3 over x, x plus 2 would be equal now to 1. We would now multiply both sides of the equation by x, x plus 2, so we'd have 2x plus 3 would be equal to 1 lot now of x, and then we'd have x plus 2. We would expand this out and get a quadratic, so we've got 2x plus 3 is equal to x squared plus 2x. The 2x's are going to cancel. We've got x squared is equal to 3. So x squared is equal to 3. So x would be equal to plus or minus the square root of 3. So all we've done is looked ahead and solved that equation by simply using the simplified single fraction, setting it to 1. Sometimes you might get terms in x and you might have to factor a quadratic in the form ax squared plus bx plus c. But essentially that's what we would do. We would set the single simplified fraction equal to it. Okay, let's see again why cross multiplying is not a good idea in this case. If you're still not convinced, let's go ahead and take 2 over x plus 2. Then we've got plus 3 over the quantity x squared plus 2x. Now let's introduce another fraction. Let's say we got plus 5 over 6, and then we got the quantity x plus 2 all squared. Now what I'm going to do is find a common denominator. We're not going to go ahead and simplify this as such, but we're just going to find the common denominator. So let's go ahead and just rewrite this. We've got 2 over x plus 2 plus, now we've seen that we can factor this one as x, x plus 2. Now I've got plus 5 over 6 x plus 2 all squared. So in our common multiple, our lowest common multiple, we're going to have this factor of x plus 2. And the decision is it x plus 2 to the first power, x plus 2 to the second power? It's going to be x plus 2 to the second power. We're going to have an x, and we're also going to have the 6. So our common denominator becomes 6x, x plus 2 all squared. And we would simply consider now what I need to multiply each of these fractions by to get the common denominator. So we can see in this case right now, I'd need to multiply this one by, and I'll just write here, we'd need to multiply this by the 6, and then we're going to have x plus 2. So we'd have a 6, and then we'd have the x plus 2, as I'm missing this now, these factors from the denominator here. Plus this one, what do I need to multiply this one by? Well, I'm going to have 3, and then I'm going to have now 6 lots of x plus 2. That was what I was missing here. And what do we need to multiply this one by? Well, the answer now is just the x. So when I do this, I'm thinking to myself, what am I missing from each of these denominators, or in the single fractions, and going ahead. And then you could go ahead and tidy that up. It's highly unlikely that you'll be asked to do that in an exam, but I'm just emphasising now that you can build these lowest common denominators by considering each factor to its highest power. So we've got an x plus 2, an x plus 2, and an x plus 2 all squared. We take the x plus 2 all squared. I've got an x, so we need that in there, and we've also got a 6. Now if I had, for example, here 12, then we would have 12 as the lowest common multiple, and we'd have to consider now multiplying this one up by 2. So that is, before we go ahead and expand it out and tidy, that would be now the fraction if we combined them all. Let's go ahead and look at another example. Let's take a fraction now, and we'll go for x, and let's have 2 over x minus 2. So we'll have 2 over x minus 2, then we'll have minus 3x plus 1. And we just need to be careful with this as we've got the negative. And then we'll have x squared minus x. We'll go for minus 7x minus 10. And then we will have on here, in fact, let's have plus 10. So this will factor minus 1 over x minus 5. So we might be asked to express this as a single fraction. So let's go ahead now and factor this. So I've got 2 over x minus 2 minus 3x plus 1, which I'm going to put in brackets now, just so when we're actually combining this, we don't go ahead and do anything silly. We've got now x minus 2 and then x minus 5. That now is the denominator of this fraction factored. Then we got 1 over x minus 5. So in these cases, it's not always obvious to see what the lowest common multiple is. As soon as we factor a quadratic expression, we can see that it's going to be fairly straightforward. So from here, what we'll do is look to express this as a single simplified fraction. The lowest common multiple is going to be x minus 2 multiplied by x minus 5. We can see that's the case. We've got these two linear factors, and we simply need to take each one to the highest power. So we're going to have x minus 2 multiplied now by x minus 5. So what did I need to multiply this fraction by? The answer is the for x minus 5 factor. What did I need to do to this one? The answer is nothing, as it was already over the lowest common multiple. What did I need to do to this one? I needed to multiply top and bottom on numerator and denominator by the x minus 2. So let's go ahead and expand this. We got 2x minus 10 minus 3x minus 1 minus x plus 2. And that's all over now the x minus 2 multiplied now by the x minus 5. So this is a typical question that you might get in an exam. And later on in the question, you might be asked to find the derivative of it, or do something with it, or treat it as a function and look at some maximum or minimum values of the function. So this is kind of just some work with algebra that leads up to these things. So what we've got then, we've got now 2x, and then we've got minus 3x minus x, which is going to give me minus 2x. I've got minus 10 minus 1, which is minus 11, plus now the 2, which is going to give me minus 9, and that's now over these two linear factors of x minus 2 multiplied by x minus 5. So can we tidy this up? We could, of course, take the negative out and write this as minus 2x plus 9 over x minus 2, and then we'd have x minus 5. So that's a single fraction in its simplest form. And we've done that now by simply going ahead and looking at factoring these. So if you want to try some, get some quadratic expressions that factor and go ahead and work with those. If you're unsure, again, if your answer is what the mark scheme has got, just go ahead and plug in some values for x to theirs, plug them into yours and check that they are the same numeric value. So in this particular case, we couldn't have x is equal to 2 or x is equal to 5, as we'd have 0 in the denominator. Let's look at another example that we might have, and we might be asked to express now 3, let's take 3 minus, and we might have, for example, now let's say 2x over x squared minus 1 plus 7 over x minus 1, and we might be asked to express this as a single fraction in its simplest form. What I like to do with this 3 is just write it over 1. You certainly don't have to, but it might help in terms of looking at your lowest common multiple. So what we've got is 3 over 1. Now here I've got the difference of two squares. So when we're looking at the lowest common multiple, we've actually got 2x over x plus 1 multiplied by x minus 1. And then we got plus 7 over x minus 1. So in this particular case, we might think, well, the lowest common multiple is just going to be the product of these. And quite clearly multiplying by 1 will give us the same value. But it isn't. If we look now, the lowest common multiple is going to be x plus 1 multiplied by x minus 1, or x squared minus 1. And that gives us now our lowest common multiple. So what did I do to this fraction? Well, I need to multiply that by the x squared minus 1. Minus 2x, what do I need to do to this one? The answer is nothing, as I've already got the lowest common multiple. Plus 7, what do I need to do to this one? And it's multiplied by the linear factor of x plus 1. So let's go ahead. We've got 3x squared minus 3 minus 2x plus 7x plus 7 all over the difference of squares, x squared minus 1, which I'm going to leave like so. We could write it as x plus 1, x minus 1, but that would be perfectly fine. So what we've got then is 3x squared. I've got minus 2x plus 7x, which is plus 5x. And then I've got now minus 3 plus 7, which is going to give me plus 4. And that's all over now x squared minus 1. My next question is, can I factor this? And just looking ahead, that's going to give me 12. So in terms of fractioning it, we can't factor that. So that's a single fraction in its simplest form. Do look out for the ability to factor the numerator, as often some of these drop out to be 1 over x plus 1 or 1 over x plus 2, for example. So do check that once you're at this stage that denominator, sorry, the numerator can't be factored anymore. So there we go. That now is adding and subtracting algebraic fractions. The take-home message is you don't cross-multiply. Cross-multiplying here would be a complete mess, as we've seen in all of the other scenarios. We consider the lowest common multiple of the denominator, and we write equivalent fractions and express these as single simplified fractions. And the addition and subtraction doesn't really matter. You just have a different operation in the numerator.